Hello students and welcome to lecture 6 part A. In this lecture we are going to talk about 2 and 3 force members. We are going to get to know them and we will also solve a brief problem at the end of this lecture. So what is a 2 force member? It is a body acted upon by only 2 forces. So there are only 2 forces applied at distinct points. So the points at which these forces are applied will be distinct, means different points. But important thing is that the body will be in equilibrium. So we will have 2 forces, which is for example here force A and force B applied at distinct points. So distinct points can be point A and point B. So 2 forces applied at 2 different points and the body will be in equilibrium. Now in this case, if you look at this figure A, we see that we do not know whether the forces are equal or what angle they are applied at. So we cannot say whether the body will be in equilibrium or not in equilibrium. So we have certain conditions to see whether a 2 force member is actually in an equilibrium or it is not in equilibrium. So for it to be a 2 force member, it must satisfy these 3 conditions. One, that the forces must be equal in magnitude. Secondly, they must be opposite in direction, and finally they must be collinear. Okay, so let's see. To satisfy the first and second condition, if you look at this second figure, figure B, we see now we have made these forces equal in magnitude. So FA and FB both are equal to F. So we say that these forces are equal. Secondly, to satisfy the second condition of equilibrium for a 2 force member, the forces must be opposite in direction. Okay, so what we did is we made them acting opposite in direction. So if this is acting upward, the force A is acting upward, the force B is acting completely downward in a certain specific angle, so that they are acting in opposite direction. Now we see that in this case they have a line of action that are separated by a specific distance. Okay, so the line of action of both the forces are separated by some distance d, and we know when we have 2 forces that are equal and they are acting in opposite direction and they are separated by a certain perpendicular distance, what they will create is a couples moment that we discussed in previous lecture. Okay, so again it will make the body rotate, so it will not have an equilibrium state. Okay, now that is why we need this third condition for them to be collinear. Collinear means they must be in the same line, or their line of action must be the same. So if you look at this third figure, now you see this is having a same line of action. Both the forces are having same line of action, so we call them collinear, having the same line of action. The forces are equal, they are opposite, and they are collinear. So that is the case where we would call this a 2 force member satisfying the equilibrium, all 3 equilibrium conditions. Okay, a very simple basic example of this would be a simple straight member that are either in tension or in compression, as you can see in the figure here. If you see, the forces in this case can be, if they are equal and they are opposite and they are having the same line of action, then we would call it as a 2 force member satisfying all the 3 conditions of equilibrium for a 2 force member. Okay, now this is a very basic understanding of a 2 force member. Now we move to the 3 force member, where we say that it is a body acted upon by exactly 3 forces. So there will be 3 forces instead of 2 at 3 distinct points. So they will be acting at 3 different points on the body, but the body will have to stay in equilibrium as the action of these 3 forces. Now there can be only 2 conditions in which this is possible, and the first condition is given in here in figure A, where the forces are coplanar. Coplanar means they are acting in the same plane. So if you have a plane like, for example, x and y, okay, so all the forces are in this plane. There is no component of any of these force that is in the z plane, which should be either into the screen or out of the screen. Okay, so they are only coplanar forces, so that must be the first condition for the equilibrium. Secondly, the forces are concurrent. Now concurrent means that the line of action intersect at a single point. So as you can see, the line of action of these the F3, the line of action of F2 and line of action of F1, they all intersect at point O. Okay, so this is the case where you can say that the body can be in equilibrium. Okay, now this is the second point. If they are intersecting only at a single point, then we can say that this is a three-force member because it will be able to get into the equilibrium state. Okay. Now the second case, which is given here in figure B, which replaces the second condition for the equilibrium, like for example when they are not parallel, they can be concurrent. But if they are not concurrent or not meeting at a single point, the second condition is that they can be parallel. Okay, so if it is in a parallel system, this is the second condition where the body can be in equilibrium, which means that the forces acting downward will be equal to the forces acting upward. Okay, so it's coming up from the equation that we already know, the equation of sum of forces is equal to 0. Okay, but in this case you also have to check that the moments are also equal to 0. Okay, so when this is the parallel case and these conditions are satisfied, we would say that okay, now this body is in equilibrium. So for a three-force member to be in equilibrium, there can be two conditions. The first condition is either the forces are concurrent, means the line of actions are intersecting at a single point, or it can be parallel system of forces where you again have to satisfy the equations of equilibrium. Okay, now let's look at a brief problem given here where we have to find the force F1. So we do not know this force and we know the F2, we also know the F3. Okay, so this is known and this is also known. Also keep in mind we also know the distances, so we know the 2 meter and 6 meter distances, and we need to find out the F1. Now for it to be a three-force member, that means the body as itself is in equilibrium condition. Okay, now it is very simple. All we need to do is apply the conditions of equilibrium. So that would be summation of forces equal to 0, summation of moments are equal to 0. Okay, so summation of moments can be at any point. Moments about any point must be equal to 0. Okay, so let's see and try to solve this problem. Okay, now I will try to first draw a diagram with the forces on it. So we do not know this F1, this is unknown, but we know this force which is actually F3, there is 20 Newton. We know another force that is acting downward here, F2, and this is actually 60 Newton. Okay, we know the distance, this one, which is 2 meter, and we also know this distance, that is 6 meter. Okay, now for the first equation of motion, which is the very basic equation of motion, stating that sum of forces. Now if you are talking, because these are parallel forces, vertically parallel, so we can say that the sum of forces in vertical direction will be equal to 0. And what forces do we have? We have F1, okay, that is acting upward, plus the second upward force is 20 Newton, and will be equal to the forces that are acting downward. Or you can again say that if you are talking about this one, so you can take the force that is acting opposite in direction as negative. Okay, so 60 Newton is acting downward, so you just take it as negative and then you make it equal to 0. Okay, this gives you the equation of motion, like summation of forces in a vertical direction is equal to 0. Okay, and then when you solve it, you get F1 is equal to 60 goes on the other side, so it becomes positive, and then 20 goes on the other side, it gets negative. So you get F1 equal to 40 Newton. Okay, so a very simple case scenario that you can actually try to solve and find out the conditions for the equilibrium. If you know the conditions for the equilibrium, it will actually helps you very easily solve the problem. So all you need to do is you need to know that the sum of forces in vertical direction is equal to 0, sum of forces in horizontal direction are equal to 0, and then sum of moments about any point. So if you are talking about this point, okay, so let's say this is O, this point is, let's say, A, and this point is equal to B. Okay, so if you are talking about this point, so you can say that sum of moment about O is equal to sum of moment about A is equal to sum of moments about B, and they will be actually equal to 0. So whatever point you take, the moment of the sum of moments at about that point must be equal to 0. So that is the second condition that you can apply, which you do not need actually for this specific question, but just so you know how to solve these problems. Thank you very much, and I'll see you in the next lecture, in which we are going to talk about reaction forces and the support reactions. Thank you very much. Take care. Bye.